Hey guys, welcome back to the channel. In one of our recent videos, we spent a good amount of time optimizing a React app and reducing its bundle size down from 1.5 MB to under 700 KB. So naturally, the next step was then to deploy that React application inside a container. So we created a Docker image with everything the application needs in order to build and run it. And the size of that Docker image turned out to be over 2 GB. And that's the part that should raise some eyebrows. Well, obviously, a Docker image is going to be bigger than your JavaScript bundle, as the Docker image contains the operating system, the runtime environment, dependencies, build tools, and everything else we've decided to package into that environment. But still, it should not be over 2 GB. And just to put that number into a perspective, let's look at some applications that are actually doing a lot more than serving a few static files. Take Jenkins here, for example. Jenkins is a full automation server. It's running Java, the Jenkins application itself, plugins, libraries, and a whole lot more. And the current Jenkins Docker image sizes are in the range of 250 to 300 MB only, depending on the variant we're running. So the obvious question here becomes, what the hell did we even put in our React image? And that's what we're going to find out in this video. We're going to take the image apart, look at where the size is actually coming from, and then rebuild it properly. We're going to look at the base image, the build context, Docker layers, and most importantly, the difference between the environment we need to build our React application in and the environment we actually need to run it. And by the end of this video, we're going to take that oversized image and see how small we can realistically make it without changing a single line of React code. So let's go ahead and optimize this React image. Here's the Docker file we're starting with. There's nothing particularly crazy here. In fact, if you search for Dockerized React app, you've probably seen something pretty close to this. We're starting with our base image, which is node version 22. We define a working directory, and then we're copying all of our application files into the image. We then install our dependencies, and then we're installing the package serve to serve the resulting dist folder on the port that we have exposed, which is port 3000. And then in the terminal, I'll type in the command docker build. I'll give the tag name to the image as React app, and then I'll simply click on enter to build this particular React image. Then we can run the docker run command to start our container. And just to see if the application is running, we'll open the browser and type in localhost 3000. And as we can see, our React app works. But the size of this React app image, as you can see on Docker here, is well over 2 GB. And that's the important part here. The problem is that a working image and being a sensible production image are two very different things. So let's inspect what Docker actually built. I will close the container for now, and I'll run one of my favorite Docker commands, docker history, on the image React app that we just built. And it will help us see the image as a collection of layers. And now you can start seeing where the problem is. We have downloaded this node 22 base image. We have then copied all of our application folders. We have installed our dependencies using npm install, and then we installed another package serve just to serve our application. If you look at the logs here, the biggest contributor to the size of the image is the node 22 base image itself. This very first base image line is something everybody just copies from a tutorial and never look at it again. But the thing is, node 22 here is the full Debian based image. Before you've even added a single line of your own code, you're already carrying 1.64 GB of content. And that's not the size of React or your application. It's just the base image you've built your React application on top of. And since our goal is to build a React application, we don't need a general purpose operating system with every tool imaginable. And what a lot of people don't know is that there is a smaller node variant available. There's an Alpine variant of basically every official image. So instead of using node 22, we'll use node 22 Alpine, and it's built on the Alpine Linux instead of full Debian. It has the same node runtime, but contains a radically smaller operating system underneath. As you can see here, the node 22 Alpine image is just 232 MB in size compared to 1.64 GB of node. So just simply swapping the first line of your Docker file, the image will drop your starting point from about 1.6 GB to roughly 230 MB. It's the same node version, same npm, same ability to run your build. You will just not be carrying an entire general purpose Linux distribution which contains dozens of tools you'll never actually use inside a container, which we are just using to build our React application. So in the terminal, we'll go ahead and build this image again. We'll give the tag name as React App Alpine, and then we'll see what's the size of the image. Our build is over now. It took roughly 90 seconds. And if we now search for our React App Alpine image, you will see that the size of the image has dropped to just 800 MB from 2.18 GB. And that's a significant win for us. Now, just to check if our application still works or not, we will run our container using this particular image. So we'll type in the command docker run, and this time we'll be using the React App Alpine image. We'll go back to the browser and refresh the page. and our application still loads, just this time with a much smaller image size. Now let's move on to our next optimization step. We'll run Docker history on this new image, and if we scroll a little bit up, you will see that there is another huge step before Docker even starts building, and it's our copy command. And notice how it's sending 263 MB of build context to our Docker daemon. And as you can see here, this step runs even before we run any of the steps to build our application. Now this command is used to copy the build context into the image. Our current command is copying everything from our project folder into the build, and as of now it includes the node modules folder. It even contains the dist folder, which contains all the assets from a previous build. And the thing is, Docker doesn't actually know which files to actually skip while copying build context unless you explicitly tell it using a dockerignore file. So let's go ahead and create a dockerignore file. And this file does the same job what gitignore does for git. We're basically telling Docker which files should not be included. So now in this file, we'll copy some of the standard folders that should not be included in the Docker image, which also includes your node modules and your dist folder. And after adding this, let's run our build command again. And while running the build itself, you can see that the transferring context log here is just mentioning that 1.18 KB of content is getting copied into the Docker image. And if we now run the Docker history command again, you will see that the build context that was copied is only 233 KB. Now let's go ahead and discuss the biggest concept that I wanted to cover in this video, which is the build environment versus your runtime environment. And we will get into the actual reason this image is so large. Looking at our original Docker file here, we'll ask a very simple question. What does this container actually need to do after the application has been built? And our answer is it basically needs to serve all of the build files. And these build files are just plain HTML, CSS and JavaScript assets. We do not need node environment, we do not need npm, we do not need Vite and all of the other dev dependencies which we installed just to build our application. So we have got a mismatch here in our approach. We are using one environment to do two completely different jobs. The first job was just to build the application. The second job is to serve the finished application. And those two jobs don't need the same environment. Since we are using the npm package serve here to serve our build assets, and since we use npm and the node environment to run the serve package, we are tied to using node in our runtime environment too. But there are other much lightweight tools available to serve your build assets, and the most popular one which developers use is Nginx. And since we already realized that our app needs two separate stages, a build stage and a serve stage, we will convert our Docker file into a multi-stage Docker file where we will be solving this exact problem. So let's rewrite our Docker file. I've now converted our Docker file into a multi-stage build. Let me just collapse the terminal a little so you can see the entire Docker file. And the biggest giveaway here that this is a multi-stage build is that you will see multiple from commands. The first stage we're using the node 22 image to build our application, and in the second stage we're using the Nginx image to serve our application. In the first stage we are doing everything that we need to build the application. We have node npm v TypeScript available here. We are running our build command which will generate our dist folder, and basically our first stage finishes with that particular step. We also name this particular stage as the builder stage, and this is important because this particular stage name can then be used to refer assets into a different stage, as you can see down here in the second stage. So in our second stage we start from a completely new image from Nginx Alpine, and we only copy the output files that we need from the build stage into this runtime stage. So as you can see from the command here, from the builder stage we're just copying the dist folder under the folder share Nginx HTML so that we can serve our build files. And that's the key line here. We're not copying the entire builder image. We're just copying one directory, which is dist. Everything else stays behind in the build stage itself and will not be included in the size of your final image. So the fundamental idea here behind this was the environment required to build your application. It doesn't have to be the environment required to run your application. So let's go ahead and build a new image with this updated Docker file. We'll name our new image React App Nginx and hit on enter. Our build is done, and now let's compare the size of the new build with the original. And as you can see, the size of this image is just 95 MB, and that's a dramatic change from the initial image that we started from, which was 2.18 GB in size. And just to see if our application still runs after such a drastic change in image size, we'll start a new container with this image React App Nginx. Just this time we'll be mapping the port 3000 on our local host to the port 80, because if you see in our Docker image we have exposed the port 80 this time. We'll hit on enter in the terminal. We'll go back to the browser and just refresh our application. And as you can see, our application still runs. And you can also double check this from the container logs here that it's this React Nginx container which is currently serving our application. Now I do not want to just stop this video at the size difference. Let's go to the containers tab and we'll open a new terminal inside the container and we'll list the contents under the share nginx HTML folder using the list command. And you'll find that all of the build assets of a React application reside here. You can also check the size of the build assets that we have using the du command. And as you can see, our assets are just 1.4 MB in size. And it is this part which makes the whole thing click. Our application might only be taking up a few MBs in size, but the image is larger than that because we're not just shipping our application, we're also shipping the runtime required to serve it. And that's completely normal and expected. The thing is, your image should just not be 2 GB in size, whose entire purpose is just to serve some static React build files. So our final build image size 94 MB is much more acceptable than what we started with, which was 2.18 GB in size. So the goal wasn't to make the Docker image size small. The goal was actually to make sure that we are not shipping things that we do not need to. We do not need to ship an entire node runtime just to serve some static JavaScript and CSS files. And apart from introducing Nginx, there are also a few other things that we did differently this time in our build step, which is we have first copied the package.json and package log.json file into the build context, and then we use the command npm ci to install our dependencies instead of npm install. And only after that did we copy the rest of the files and actually ran our build command. And there's a reason behind these changes. There's a reason why we first installed all of our node modules before copying the rest of the source code. And the reason is Docker layer caching. Docker caches each instruction as a layer and it reuses a cached layer if nothing that layer depends on has changed. So if you copy everything at once like we were previously doing and then run npm install, changing even a single line of code in one of your components would invalidate that layer and force a full reinstall on every build. But if we split our copy commands into two different commands like this, where we first copy our package.json and package log, our dependencies will only get installed when package.json or the log file actually changes, which on a normal day never happens. That's a very small change to the Docker file, but on a project with large dependency tree, it can make a very noticeable difference to the build times. Because for some of the projects, installing all of the packages from scratch can even run up to 5 or 10 minutes. The second change that we did using npm ci instead of npm install, it's just designed for clean and reproducible package installs. npm ci follows the log file diligently and it will fail if your package and log file do not agree. So in a use case where you generally would want the same dependency tree, it's better to use this command. Now, unlike what a lot of other tutorials do, I will also explain the Nginx stage. Here we are running three main commands. In our first command, we're basically just clearing up the Nginx HTML folder using the rmrf Linux command. The second command we already discussed, where we are copying the build assets from our build stage into the Nginx HTML folder that we just cleared. But in our third command, we're also copying one Nginx configuration file as the default Nginx configuration, which we had placed into the root of our application. In the future, I will make an entire video explaining how you can use Nginx with React, but let me go ahead and cover the most important lines in this particular configuration. The most important line here is this particular location configuration, which I'll explain what it's doing by first going to our application. Here, if we click on one of the products which are available on the dashboard, we land onto a details page. Now the thing is, the root of our application is mapped to the index.html, which is inside the Nginx HTML. But what about other routes? For example, what we have here, the route product 1, there is no actual HTML file which is mapped to this particular route, and Nginx will have no idea what to do in that case. Internally, we know in React router is handling all of these navigations, but Nginx does not know what React router is. It looks at the file system and it asks whether there is a file called product1 being the product ID here. So this particular configuration is just giving Nginx the fallback instead. Without this particular configuration, Nginx will just return a 404 because your browser will simply not just receive the JavaScript necessary to run this React app. So what this line here is essentially saying that if you are able to find an HTML file, serve it. Otherwise, just fall back to index.html. And once index.html loads, our JavaScript build file, which has the React code, also loads. React router will see the route product1 and React will take it over from there. So this is the most important configuration which people just copy without knowing what it's actually doing. And another useful thing in this configuration is this particular property, which also directly connects back to our last video. Remember how Wheat gives our production assets file names containing content hashes? We also created separate vendor chunks, which again have hashes. And we did all of that chunking so that the user's browser can cache those files and it does not request them again when the user reloads the page. And what this property here in Nginx configuration is basically doing, that it's telling for all of these file extensions, add the cache control header with an expiry of 1 year. So your browser will be able to cache these files for a very long time. So as a conclusion to this video, let's compare the two images one more time. Let's look at what survives in the bloated image. We have the node environment here, we've got the application, we have the installed dependencies, and in this case, node environment is the build environment and also the runtime environment. Now let's look at the optimized image. We have a React output inside the Nginx HTML folder, we have the Nginx configuration and other underlying Nginx files, and that's your entire application runtime. So we have the same React application with the same features with just a smaller build image. We stopped sending unnecessary files into the build context using dockerignore. We introduced multi-stage builds so that our final runtime build does not include the node environment. And now we have an incredibly optimized infrastructure for serving our React app. So as a takeaway, don't look at a Docker file as a recipe you're supposed to copy. Look at it and ask, what does this application actually need at runtime? For our application, Node, Wheat, the dev dependencies are only needed to build it. But once that build is finished, all we have is a directory of static files. So it does not make sense to also ship the entire build environment just to serve a few files. We can also say that why would we ship the entire kitchen when we just want to ship a takeaway order? So that was it for this video, and if you want the exact Docker files, the Nginx configuration and the commands I used in this video, I'll leave the link to the Git repo in the description below. If you learned something new, hit on the like button, and if you're finding these videos useful, consider subscribing to the channel as I'm posting similar deep dive videos on a weekly basis, and I'll see you guys in the next one.